Here says Sam deposits $500 into a savings account that pays 2.4% per A. Per A just means per annum per year, which means nothing. It's always going to be per A or per annum. And it's compounded annually. Compounded annually, how does that affect the equation? Does it affect my interest? No, because I'm dividing by 1. Does it affect my years? No, because I'm timesing by 1. Because it compounds only once a year, right? So the number of years is actually equal to the number of compounding periods. Now, let's go and let's think. Say, totally separate question. I'm going to put it on a separate page so that you don't think it is part of this. So say I solve out a compound interest question, okay? Are we all paying attention? Because people will get this wrong. I'm solving out a compound interest question. We agree? And I get 7.4639 blah, 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 years. When am I allowed to round with rounding rules? When am I allowed to round? You've been taught this since you were little. In the answer. That's it, right? In the answer, you're allowed to round. So if I asked you, we're paying attention because this is very important. In some place we can make mistakes on it, something super simple. If I ask you for the number of years, and I say whole number, to reach at least $8,000, how many years would it be? It's going to be 8, because you're going to round up. Because if you round down, it wouldn't make us actually have $8,000, okay? So that would be 8 years. Most people can do okay with that. But sometimes on the test, they will ask you for compounding periods. Okay? They'll ask for the number of compounding periods. They won't ask for the number of years. They'll ask for the number of compounding periods. Okay? Let's think about it this way. When am I allowed to round? In the answer. That's it. Correct? So, if I ask you, say the answer. This is my answer for x. Right? That's my answer for x. We're going to keep that. If I ask for the number of years it takes to make at least 8,000, you put 8 years. Right, Simon, who has his phone over top of his calculator and thinks he's sneaky? Okay. Good. Good. Cool. Okay, so the years would be 8 years. All right. Now, if I ask you for compounding periods, wasn't born yesterday. It was a nice fall day in September 1983. My dad was in harvest at that time, you know, things like that. You can also tell when someone just puts it into the actual calculator thing because it's thin. He put it right on his calculator thinking that was sneaky. It didn't work. All right. So, compounding periods. If I say how many compounding periods, you would say to me, how many times does it compound? That's what you have to know, right? So if I say compounding periods, you'd say how many times does it compound? And I say it compounds semi-annually. Do I round to 8 and then times it by 2 because it does 2 times a year? No, because when would I be rounding? Before the answer if I did that, wouldn't I? Everyone paying attention? This gets done really poorly. I'm not joking. So semi-annually, if I ask for the compounding periods semi-annually, what you're going to do is you're going to take x, which is 7.4639 not round it, because I'm not allowed to round till the answer, correct? And times it by 2. So everyone try that out. 7.46398 times 2. That's what calculators are for. Calculating. Yeah. Okay. What do we get? 14.8 blah 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 blah, which is how many compounding periods? 15. If I took the 8 and multiplied it by 2, how many would I get? 16. Would I be wrong? Yep. So if I took the 8 years and I rounded it and I multiplied it by 2, I get 16 compounding periods. It's not. It's actually 15. Do you see that? So you cannot round to the end. What if I say compounds monthly? What would be the difference? I would take 7.46398 ... and I multiply it by how many per year? 12. So type that in. Everyone's typing it in. I don't see your hands feverishly moving. Type away. What do we get? 89.56, blah, 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 right? So what would that be to the whole number? 90. Okay, what if I rounded first? I would go 8 times 12, which is actually 96, which is wrong. Do you see how there's a big difference if you round your number first, your years first, and then find compounding periods? So when are you allowed to round? In the answer. So I would take my 7 decimal blah, 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 and I would times it by the compounding periods per year, and then I'd round up. Does that make sense? You see the difference? Okay. This one was, it's a past release diploma question. I just gave it to you. Now, or one that they gave to us. Anyways, it was nice because it had annually on it. Annually means your years is going to be equal to your compounding periods, correct? Because I would just take my years times by 1. It's not going to change anything. So I want you to tell me, before we even do this, I want you to tell me, what does this 500 represent? The initial amount of money that Sam went into the bank with, correct? Sometimes they will just give you an equation and ask you, what does it represent? What do the numbers in the equation represent? And you'll say the 500 represents the initial amount of money that Sam went in and deposited into her bank account, into her savings account. Okay, what does the 1.024 represent? How would you explain that? What's the interest in the decimal form? The 0.024. So when we explain this one, we'd have to say, well, you take 1 and you subtract off 1, because that takes 100% of the original off. And what I'm left with is 0.024, or you could say it's 0.024 is more than 1, because this equation is actually 1 plus it, which would be the interest rate. You have to explain thoroughly, you guys. Okay? And it'd be 0.024 times 100 would be 2.4% per annum, which matches the percentage that they gave us. We agree? So we have to be able to explain these things. So here it says, determine how long to the nearest year that it will take for the investment to be worth at least 800. So at least 800 means whatever year I get, I'm rounding up, right? Because if I round down that 7, I wouldn't have made that much money. I'd be under. And people are like, well, what does it matter? Well, if you need $800 to go out and buy something, and you are at 700 and something, they're going to tell you to go away and come back in a year, right? Because you can't buy it, because you don't have enough money. So it says at least 800, you have to round up. So let's fill it in. Let's see how we did. So 800 would go in for our final, equals our initial. Isn't this a nice question? They basically filled in 3/4 of it for you. Like, that's kind. So then 1.024 to the x. Now, what did I tell you? If you have your final and you have your initial, what are you going to always do first? Divide them, right? Whether you put in your calculator or you're converting it to a log, you're going to have to do that, or your calculator is going to be a really large window. So we're going to divide by 500. And we're going to get 8 over 5 equals 1.024x to the x. Everyone, y1, y2. We're going to do it algebraically after this. We're practicing both because I want you to know every single thing. So y1, y2, I don't care if you did y1, y2 before, you're doing it again. So this can be your y1, 8 over 5. And your y2 is going to be 1.024 to the x. Every single person is following along, and every single person is using their calculator. Now, I myself always start with a window of 10, the just standard window, and see if it works, and then go from there if it doesn't. And if it doesn't, it's often my x max that just needs to be increased, but sometimes it's my y. So if I use my standard window and I do second, trace, 5, enter, 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 it's going to get mad at me. It says no sign change. What does that mean? I need to do what? X max. 99% of the time it's my X max that needs to get changed. So I go to my window and I make my X max be 20. Because if I can't see where it crosses, my calculator can't find where it crosses, right? But we always just try it right off the bat on the standard window anyways. Second trace 5, enter, enter, enter. And I get 19.81. Did you get that? Did everyone get that? 19.81. So my X equals 19.81. 7557. How many years is that? 20. What if, you guys, what if it was 19.1? Paying attention, what if it was 19.1? I would still put 20 because 19 wouldn't be enough to go buy that object. You wouldn't have $800. Okay, you would have to round up no matter what. Does that make sense to people? Okay, how do we do this algebraically? Off to the side, we're going to do this algebraically. So I have 8/5 equals 1.024 to the x. I can do every single exponential word problem by converting it to a log. Right? I need the exponent down. If I need the exponent down, I have 3 pieces, I can convert to a log. 1, 2, 3 pieces. We agree? I can convert to a log. My equation for conversion is y equals a to the x, and then x equals log base a of y. Which one am I filling it into? Equation 1 or equation 2? Which one am I like matching it with? 1 or 2? 1, right? Because 1 doesn't have a log, and this equation doesn't have a log. We agree? Do you see that? So this is y, this is y, this is a, this is x. Some people try and match it with the log equation, and they're like, I don't know where to put it, because there is no log. Well, exactly. Don't put it with the log one if there's no log, right? Then it converts to the log one. So we get x equals log base a of y. So we're going to get x equals log base 1.024 of 8/5. Everyone type that into your calculator. Log base 1.024 of 8/5. Everyone type it in. Practicing with your calculator how you do it. Log base 1.025 of 8/5. Depending on what calculator you have, you're doing it differently. Did you get the same answer? 19.81? Yeah. If this is a word problem in a written response, you're going to have to show the algebra on it, guys. You can't just Y1, Y2. So it's 19.817 ... which is still 20 years. You see that? You see how we did it both ways? Every single exponential word problem can be done both ways. So let's look at B. Modify the exponential function to reflect an interest rate of 4% compounded annually. What's changing with it compounded annually? What's in that equation is going to change? That 1.024 is going to change, correct? What's it going to change to? 1.04. Now, what if I change this up again and I say compounded semi-annually? So it's still going to be 4%. That's not changing, but I'm compounding it semi-annually. How is your equation going to change? We're going to get y equals 500. That's not going to change. But we're going to get 1 plus what? 0.04 divided by 2. Where else does the 2 go? By the x. It's going to be multiplied to it, correct? So you would get y equals 500, bracket 1.02 to the 2x. You see how it can change? That's how they can ask questions on your diploma. It doesn't have to just be a straight up like, here's a word problem, give me an answer. It can be change things, describe things, explain things. compare, contrast. Doesn't say contrast, just says compare. If it says compare, they will be looking for 2 similarities and 2 differences, just so you know. If ever you see the word compare in a question, 2 similarities, 2 differences. All right? We'll go down to this one. The half-life of carbon-14 is approximately 5,730 years. So it halves every 5,730. Does it make sense that it's here in the equation? What goes in that spot? Starts with a P. What goes in that spot on the bottom of the fraction? The period. So it's how long it takes to half, to double, to triple, right? This one halves every 5,730 years. This thing really has a slow rate of halving, correct? Like, we have to wait 5,730 years and then it halves. And then, like, it takes quite a while to half, correct? But that is the period. And our equation has the period on the bottom and time to final on the top, correct? Then it says, as a sample of carbon-14 decays, the percentage of carbon-14 remaining P at any time, that's the percentage remaining. Where T is the approximate age of the sample in years. So this is how long the sample is in years. They have to, if they give you an equation, they have to tell you what the variables stand for. They have to. You can't just give you variables and not tell you what they are. Okay? So here it says, to the nearest year. Determine the approximate age of carbon-14 when 33% of the original amount remains in the sample. 33%. So where's that going to go? In for P. We're going to do it with our calculator, and then we're going to do it algebraically. I'm going to start. So 33 equals 100. What's the first thing I do when I have a final and an initial? Divide the initial over. You are correct. Either way, solving with my calculator or changing it to a log, that has to happen, right? So I just do it every single time because I can't do anything without it. So I'm going to get 0.33 equals a half is just 0.5 if you want to write it that way, to the T divided by 5730. Okay, everyone's Y1, Y2. Try it out. Now think, the half-life is 5,730. T is going to be, I don't know, a bit bigger than that probably. So my X is going to have to be pretty big, don't you think? So try that one out, Y1, Y2. Go fast. Like a fox. So I'm going to make my window quite large because I don't think it's going to cross for a while. So I made my X max be 10,000. If this is 5,730, I made my X max be 10,000. So second trace, 5, enter, enter, enter. Did anyone get anything? Make sure your X max is 10,000 because it needs to be quite large, right? Or it's not finding it. Did everyone get 9,164 decimal 9177? Yes? No? Make sure your X max has to be at least more than 9,164 or it is not finding it. Now remember, it halves in 5,730, so it's going to be to a third. It's going to have to be larger than that, right? So I got T equals 9164.9177, and it wants to the nearest year, and T is a sample in years. So to the nearest year, it's going to be 9165 years. And if this is a written response, I would say It says the approximate age, and you have to reiterate what's in the statement. So about carbon-14. So the approximate age of the carbon-14 when 33% of the original amount remains in the sample is 9,165 years. This was the only English I was really good at, because you literally just restate the stem of your question, right? Don't be lazy, right? Carbon-14 and stuff like that. They will dock you if you don't. Okay, so this was Y1, Y2, correct? That's how I did that one. But if this is a written response, we're going to have to solve it algebraically. Okay? So we're going to go over here and do it algebraically. And so we have 0.33 equals 0.5 the t over 5730. What do I have to do when I need that t or that exponent to come down? Every single time I have to do what? Convert it to a log. So we have y equals a to the x equals log base a of y. This one doesn't have a log, so I'm going to line it up with that one. So this is y, a, x. So I get x equals log base a of y. So I'm going to get t over 5,730 equals log base 0.5, and then beside my log I was putting it in a bracket, 0.33. What am I going to have to do to get t by itself? Multiply by? Yeah, 5,730. Everyone's typing it in until you get the answer we got on the previous one. And why am I forcing everyone to type it in? Because some people try the entire unit to trust everyone else typing it in, and that's lovely. But when you get to the test, no one else is typing it in but you, and then you can't get any answers right. I've had people call me over and they're like, I don't even know how to type this in. And that is, I can't help you at that point. You need to try every single time. So type in log base 0.5 of 0.33 and then times that by 5,730. Try that out. Okay, this one says expand. Everyone paying attention? Remember, I told you as a hint to help you out, the best way to expand these is to go log base 3, and in brackets you put 27 times a squared divided by b cubed. It's often helpful if you show that all of those are separate things, correct? Now, when it says expand, we can write these all as single logarithms. The ones in the numerator just get a +1 in front of the log. The ones in the denominator just get a -1. Remember? That's all that happens. So we're going to get log base 3 of 27. Because the 27's in the top, I just have a +1 in front of the log. Do I actually have to write that? No, I'm just proving a point. Okay? Now the a squared is in the numerator, so I'm going to get a +1 in front of that. Log base 3 of a squared. And then, because it's in the denominator, I get a -1 in front. Log base 3 of b cubed. And that is expanded and great. However, I can simplify this more. Log base 3 of 27 is all numbers, correct? So type that into your calculator. Log base 3 of 27. Log base 3 of 27, it doesn't have any variables, so it can be typed in, right? What do you get? You get 3. You can also do what your calculator is doing and say 3 to what power is 27, which is 3. It's the same thing. If you have to type it in, not a big deal. So we're going to get 3 plus. Now, they could just finish it off as log base 3 of a squared, log base 3 of b cubed, but most often, what are they going to do with those exponents? Do you remember? Yeah, they're going to drop it in front of the log by power rule. Remember, the exponents can drop in front. or come up as the exponent. They can move whenever it's only when there's a log. So this 2 can come and join that 1. And this 3 can come and join that 1. But it only works when there's a log in between them. So I can get plus 2 log base 3 of A minus 3 log base 3 of B. Do you see that? How that exponent can come down in front? Which is better, the one with the exponent up or in front? The one that matches the multiple choice answer. That's the one that's better. That's it. Okay? Now number 4. They're all log base 6, log base 6, log base 6, log base 6. So it screams, put me together. Whenever they're all the same base, it screams, put me together. No joke. It should scream it at you. How can I put things together, though? What do they have to have in front of the logs? Ones or minus ones, right? Plus ones or minus ones. And if they don't, you have to take the number in front and raise it as the exponent. Remember? So here we're going to get, this 2 needs to come up here. So we're going to get log base 6 of A squared plus log base 6 of B cubed minus log base 6 of A cubed minus log base 6 of B4. Now do they follow all the rules of being able to put them together? They all have to have the same base, and they all have to have plus or minus 1s in front. Does it follow that rule? Yes, so now we can put them together. So we go log base 6, anything with a plus 1 in front, numerator, anything with a minus 1 in front, denominator. If there's more than one thing in the numerator or denominator, what do you do with them? What operation? Multiply. So this one has a plus 1 in front, A squared numerator. This one has a plus 1 in front, B cubed numerator. And then they're technically multiplied. This one has a minus 1 in front, A cubed denominator. This one has a minus 1 in front, B4 denominator. If you're feeling like this seems really familiar, it's because I gave it to you yesterday, the exact same question. What can I cancel off? The A squared cancels off 2 of these because it's multiplied. I can do this. If there's a plus or minus sign, I wouldn't be able to. B cubed cancels off 3 of these. What's left in the numerator? If it's all canceled off, what's left in the numerator? A 1. This one we're going to convert from log form to exponential. Whenever it says that, we immediately write down our conversion. So we have y equals a to the x, becomes x equals log base a of y. And I have to make sure there's only 3 pieces, right? 1, 2, 3. There's 3 pieces, so I can convert it, correct? If there isn't 3 pieces, if there's 4 or more, I have to move it around until there only are 3 pieces. So let's match it up. Am I matching it up with the one with the log in it or the one with not the log in it? The one with the log in it because it has the word log. So this matches with A. This matches with Y. This matches with X. And then I rewrite my equation. Y equals a to the x and fill it in. Y is actually x equals 6 to the x, which is 10. Done. What's the problem with B? Looks like I have, yeah, the 2's the problem. It looks like I only have 3 pieces. But what I tell you, whenever there's a log without a base, what should you immediately do? Base 10. So there actually is 4. 1, 2, 3, 4. So I have to divide the 2 over first. So I actually get 3 equals log base 10 of y. Is log starting to make a little more sense? We practice, write the test on Tuesday so that we can do these. because the hardest part of logs is see and do. See and say, what do I do? And then do. People get stuck on the do part. Okay? Now we match it up. So this one has a log. We match it with log. This is x. This is a. This is y. Y is y. That's nice. So we get y equals a to the x. So we're going to get y, which is y, equals 10 to the 3. Done. Now we're converting from exponential to log. So we write our equations. Y equals a to the x. X equals log base a of y. So I'm matching it with the exponent one because it doesn't have the word log in it, right? Y is by itself. A, x. And then I get x equals log base a of y. So I'm going to get b equals log base a of c. How are you guys doing on these, okay? What's the problem with b? There's how many pieces? There's 4 and I need 3, so what's the first thing I'm going to have to do? Divide it. It looks like I'm dividing the initial over, doesn't it? This is a word problem set up. That's all it is. I'm dividing the initial. Initial and final, both are here. I have to divide the initial over. Do you see that? Initial and final, both are there. It's the same thing. Now 7 over 2, I could leave it 7 over 2, or I could convert it to 3.5 because it's a terminating decimal. If it's a decimal that just keeps going, you can't just cut it off, because that would mean you were rounding before the answer. So if you use 7 over 2 or you use 3.5, both are acceptable. Okay? I'm going to leave it as 7 over 2 just to prove a point. So I have 7 over 2 equals 10 to the t plus 1. Now I line them up. Y, a, x. And I need to do x equals log base a of y. So x is t plus 1 equals log base 10 of 7 over 2, which is done. But what might it look like instead of this? What might they do? They might not write something, and they would be fine if they didn't write it. What do you not have to write? The base 10, right? Is log just a log, the log without a base 10? Yeah. So the multiple choice answer could actually be t plus 1 equals log 7/2. Or log of 3.5. I should do that. Do you see how they don't have to write the 10 if it's a base 10? Okay, these ones say solve the equations algebraically. So what I always check for first is, can I do common base? Can I do common base between a 10 and a 4? No. So what's the only way else I can solve it algebraically? Convert it to a log every single time. So this is my y. This is my a. This is my x. So I'm going to get x equals log base a of y. So I'm going to get x equals log base 10 of 4. What does that become? I could just write log 4, or 0.60 if I go to the nearest hundredth. With b, what do I have to do? Divide by 2 first. That's my initial and my final. They're just written backwards. So now I have e to the x equals 7. So this is my y. This is my a. This is my x. Remember, e is actually a number, just like pi is a number, and they don't have to tell you that. They don't have to tell you pi is a number. E is a number. It's not a variable. So we give x equals log base a of y. So we're going to get x equals log base e of 7. And instead of writing log base e, what could they write? What is log base e? We were just doing them yesterday. Non-regressions. The ln. Remember, ln is just log base e? So they could write this as x equals ln of 7. It's just a natural log because it gets used often in regressions and stuff like that. So they could write it as ln. And then we have to evaluate each expression using technology, or we can just use our brain cells, so we're going to use our brain cells too. 2 to what power is 4? 2. Answer. What happens when I get this? This is something very important to state. If I get log a to the c, you see how the base and the number beside are the same? Your answer is always the exponent. Because a to what power is a to the c? C. So whenever you get like log a to the c, your answer is c. So if I gave you log b to the 9, what would your answer be? 9. Okay, now I'm going to give you some polynomial stuff and you're going to help me. You don't have to write this down or anything. You're just going to have to speak, which is hard for you. Speak louder than a whisper. I believe in you. Okay? Okay. Say I give you this. What kind of equation is that? It's linear. Someone said linear. What other thing is it? Degree 1. Because the largest degree is 1. We agree? Okay, you have to pay attention at the very least. Ready? Okay, what is the degree 1 line? What is the degree? I just gave it away. What does the degree 1 graph look like? It's a line. What is a degree line graph? That's that one. It looks like a line. Now it could go this way or this way, right? It discos. When anything discos, what's about my domain and my range? Pardon? You said it. Yes, they're both elements of a real number, right? I just wasn't sure if I heard it, but I knew you were right. So my domain, quiet please, you guys are just supposed to be paying attention, so at least quit moving. Okay, domain is XER, range is YER because they disco. Whenever the arms disco, correct? Now what tells me, when it doesn't have a bracket, what is the Y-intercept? There's no brackets in the equation. What's the Y-intercept? Always. For every polynomial. It's the constant. So that's something to note. Remember, our constant is always our Y-intercept, but only if there are no brackets. If there's brackets, you don't actually have a constant. For those of you who think you do. You don't. So this right here would be my Y-intercept, because it's the constant, correct? When we're done this, if you want to take a picture of it, you can. Now, if I give you this, what does that tell you about the equation? If I give you that, what does that tell you about the equation? Your equation, remembering, is y equals ax plus b. What does it tell you about a, and what does it tell you about b? They're both positive. Why?
Because it ends on the right, and it's a positive
Y-intercept. Positive Y-intercept tells me that b is greater than 0. And because it ends up on the right, which whether it's degree 1, degree 2, or degree 3 doesn't matter, if it ends up on the right, my a is greater than 0. We agree? Okay, what about this one? What does this tell me about my a and my b? What's my a in this case? Negative because it's down on the right. What's my b? Negative because I have a negative Y-intercept. Okay, what if I give you this? What does that tell me about my a and my b? My a is negative because it's down on the right, so it's less than 0, and my b is positive because I have a positive Y-intercept. You guys remember stuff. Okay, giving you one other one. Tell me this. This is what? What kind of graph is this? Cubic. Ax cubed plus bx squared plus cx plus d. What can you tell me about a and d? A is greater than 0 because it's up on the right. What can you tell me about d? Yeah. D is greater than 0 because it's my constant. And what are my constants always? My y-intercept. Is this graph discoing? Yeah, it just does some funky stuff in the middle, but it's still discoing. It's just like a real cool disco, you know? So what's the domain and range of it? X and down to the reals. And y is down to the reals. It goes on for life, right? One more thing about cubics. Cubics can have a max and a min, like this one. And maxes and mins are turning points, correct? A max and a min, that's the definition of turning points. So this has 2 turning points, this one. What's the other thing that a point of, or I just gave, why am I keep giving away the answers? In fact, point of what can happen on a cubic? Do you remember? Point of kind of sounds like inflection, but it's not. Inflection. So a point of inflection is where it curves, right? So a cubic can have a point of inflection. Is that a max or a min? No, so how many turning points does this one have? 0 turning points. Does it affect my domain and range though? No, it's still XER, YER. Now, how many x-intercepts can a cubic have minimally? 1. Pass across to somewhere.